Hello, my name is Mark Macri. This is my presentation. And I apologize if you hear the fans on in the background. It's been quite warm the past few days, and I'd rather not shut them off. But anyways, here is my spring organic chem 2021 presentation on acetaminophen synthesis. Enjoy. Acetaminophen, here's a little background on it. Acetaminophen is a common over-the-counter painkiller used to treat mild pain symptoms such as headaches, stomach aches, back pain, etc. And I'm sure you heard of the name brand Tylenol, which you can buy at almost any superstore or pharmacy, or pretty much anywhere. Now, a little on the structure of acetaminophen. It is a benzene ring with an amine and acetyl group on 4. The acetyl group is attached to what was the amine in p-aminophenol, and there's a hydroxy group on 1. The hydroxy group on 1 is why this compound is suffixed phenol, or phen, shortened for phenol. It's also known as paracetamol. I don't know if I'm pronouncing that right, but I tried. It's also known as a few other names. It is a derivative of the compound p-aminophenol, which is a phenol group, which means there's a hydroxy group on 1, and then there's a amine group on 4, hence p or para, which means 1 and 4. Here is my procedure for synthesizing acetaminophen. First, you're going to start with 1.05 grams of p-aminophenol, and you're going to add them to an Erlenmeyer flask. The reason I chose 1.05 is because we were given 3 to start with, and I wanted to have enough to repeat in case I messed up the experiment somewhere. After you add the aminophenol to an Erlenmeyer flask, you're going to make a buffer solution of 1.25 grams of sodium acetate trihydrate and 3.75 milliliters of water. Then you're going to prepare a steam bath by putting a beaker on a hot plate and adding the aminophenol followed by the buffer solution, and then you're going to stir for a few seconds. Once that is good and hot, you're going to add 1 milliliter of acetic anhydride to the steam bath and stir for 10 minutes. Once you're done stirring for 10 minutes, you're going to cool the solution on an ice bath and wait for the crystallization to take place. Afterwards, you're going to filter the product once the crystals are formed. You're going to filter them through a Buchner funnel and allow the product to air dry. Then you're going to weigh the dried product, add it to 2 milliliters of boiling water, and then once it is all dissolved, you're going to allow it to cool again, and then weigh the newly formed crystals and record the results. So here are my results from the experiment. About 0.80 grams of acetaminophen was produced, which the experiment was a 1-to-1. So it should have been roughly about 1 gram if it was a 100% turnout. But in this case it was 80%, which is fairly decent. But the boiling point of the acetaminophen I got was 167.4 degrees Celsius, and for the IR spectroscopy, there's a peak at about 3400, 3200, and 1600. And you can see that in the photo. On the left-hand side of the screen, you can see the chemical structure of acetaminophen. And on the right, acetaminophen is known to have a boiling point of 167 to 168 degrees Celsius, which lines up with what I got. The peak at 3400 is most likely an OH bond. This lines up with the hydroxy group on the 1 of the acetaminophen. The 3200 could represent the NH group on the right of the structure, and the peak at 1600 lines up with a benzene ring, which is at the center of acetaminophen. In conclusion, all the results point to this experiment being done successfully. acetaminophen was successfully derived from p-aminophenol, reacted with acetic anhydride, and the boiling point was an exact match, and the IR spectroscopy was very close to being an exact match. And here is my works cited. Thank you for listening.